ನಮ್ಮ ಸಿಸಿಗೆ ಗೊತ್ತಾಗಲ್ವ ಯಾವಾಗ ಕ್ಲಾಸ್ ಇದೆ ಅಂತೇಳಿ. ಥರ್ಡ್ ಅವರ್ ಕ್ಲಾಸ್ ತಗೋದು ಸುಮ್ ಕೂತವ್ರೆ, ಫೋರ್ತ್ ಅವರ್ ತಮ್ಮಂತೆ ಸತ್ಯ ಮೇಡಮ್ ಸಿ ಸುಮ್ ಕೂತಾರ ಅವಾಗ ಥರ್ಡ್ ಅವರ್ ತಗೋದಿಲ್ಲ. ಫೋರ್ತ್ ಅವರ್ ಕ್ಲಾಸ್ ಅಂತ ಗೊತ್ತು, ಯಾವ ಸ್ಕೀಮ್ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು. ಮೆತ್ತಾಗ ಮಾಡಿ ಪಾಠ, ದಬಾ 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 ಬಡ್ಕೋಬೇಡಿ. ಎದಕ್ಕೆ ಬರ್ತೀರ ನೀವು ಇಲ್ಲಿ? ಬರೀ ಮಾತಾಡ್ತಾರೆ. ಹಲೋ ಹಲೋ ಸ್ಟೂಡೆಂಟ್ಸ್. Hello.
Yes, sir. Yes, sir.
1 minute. Others also they are joining. Okay. ಒಟ್ಟ ಮಾತಾಡ್ಬಿಟ್ರಿ ಸಿ ಎಸ್ ಮಾತಾಡಿದ್ರಿ. Hello. 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 Hello.
Yes, sir.
Yes, sir.
Okay, we'll start. Others they can join later. Okay. Last class we discussed
Okay.
about the set and reset latches. While using the set and reset latches with the help of flip flops, what will be the changes for the while taking simultaneously data inputs. You can see here metastable state. In this metastable state, even you have to take the any events, certain of events. For example, event is nothing but either it may be audio, either it may be video, or if you want to perform any other operations. If the certain events can cause the latch to enter the to enter the metastable state. That indicates it will give the short time of period. For example, you can take the um, I wanted to communicate for three members. While communicating with three members individually, I'm talking same information to I'm sharing to the three persons. If I'll keep on calling the separate, it will take more time. Instead of keep on calling the separate, just you have to call one person, just you have to hold it and add other calls, and you have to discuss one matter with the three members. Then you have to reduce the time. That is nothing but short time. There is for the metastable state concept. They're applying the communication system. In the mobile also there is a while communicating conference call. Someone will ask for you, someone will tell you, just you can take the conference call, we will discuss what the matter is going on. Same thing you can apply the, they're applying the metastable state in the communication system. In the metastable state, it will take only short period of time. You have to communicate to the all the persons or all the datas or all the events. Either it may be recording, either it may be audio, either it may be communicating, either if you are wanted to say the information from all the certain events. Suppose if you have any simultaneously, if you changes the keep on changing the data from one person to the another person, what you have to change, either you have to ideal for one person, either you can talk to other person. Same thing you can apply for the simultaneous changes in the S and R from the 0 to 1 and 1 to 1, 1 to 0 in the set and reset latches can cause the latch to enter the metastable state. That is for the second concept of how they are using to the industrial application for the metastable state. Suppose if you are starting data is output is q is equal to 0, then applying with the pulses in the S as well as R flip flop with the length of the borderline between the being to the short causes. See here, suppose if you are using the SR flip flop, with the SR flip flop, you will give the short causes through a borderline. How it will changes, I will show you in the circuit diagram also. Just along with enough to the cause, Q to change may be cause the circuit to enter the metastable state. Suppose if you have any events is causing the circuit, enter the metastable state must be avoided. How it is must be avoided in the short term, you will see in the any pressure state is denoted state of the Q, output of the latches or flip flop at the time any input signal changes. While communicating any input changes, you can take the next state and you have to denote the states Q output and the flip flops and latches reacted to the input changes. That is for metastable stabilized. Suppose if your output is Q of t, it represent the present state, and Q of t plus summation or QL RQ plus represent the next state, then equations for the Q into can be obtained from the circuit. Here I will show you the circuit diagram. See here how it is performed. See here, derivation of output. In the output, this is for the C here, this is for S and R, two inputs, and Q bar is outputs, and these are the select line inputs. SR 000 01 10 11. Well, applying this, it will changes to the Q and Q bar. Q plus, what is the inputs is not allowed to the this, because you have to apply the simplification for the K map. K map, you are taking this. This is one pair. Also, you can take the, this is also one pair. What is the output? Will get the this expression. You have to find out with the help of simplification, K map simplification method. Suppose in the any questions, you can see here. One assumption I question, I took this example. Suppose in this problem, any improper operation, it is what I told you now. Till now, I explain only proper operation. If you are any problem, if you are not getting the any information, improper operation, that can occur if both the inputs SR latch are 1, then change to the 0. And also you can compute the following timing chart, assuming that each gate has propagation delay of exceeds 10 nanoseconds. Assume that initially is P is equal to 1 and Q is equal to 0. Note that when t is equal to 100 nanoseconds, s and r both are changed to the 0, then 10 nanosecond later you can take the both p and q will be changes to the 1, because ones are feedback to the gate inputs. What happened after the 5 after the 10 nanoseconds? Here, this is my figure. In this figure, in this SR, I will change to the design, change the input is 1 1 to kite in 1 1. Immediately I can change to the 1 1 replace to 0 0. When you will replace the 0 0, what is the output you will get for this? P is equal to 0 to 1, 1 to 0, 0 to 1. This output also will get for the 0 to 1, 1 to 0, and 0 to 1. What it will be changes here? 0 0, 1 1, 0 0, 1 1. Same thing it will be changes, but P and Q it will not be changes. Why? Because after 10 nanosecond, still the input is not decided which input is selected. Either it may be 1 1 or 0 0. While taking the 1 1, these two 1 1s are invalid input. These two 0 0 also invalid input. Why it is invalid? Because if you consider 0 0 and 1 1, it will not change to the output for the any SR flip-flop. Because of that only you can consider as a invalid output. That you have to find out after 5 or 10 nanoseconds. Here, this complete this timing diagram of with the changing this, you will get the Q is only 1. It will not be changes. Suppose in the set and reset latches by using the switch debouncing. Switch is nothing but on and off condition. When it is the switch is on, what happened for using the SR flip flop for data set as data select lines, and what happened for the data output select lines. Here, when the mechanical switches is open and closed, you can take the any mechanical or any electrical switches or any mobile switches also. Just is you can open and close. When the open and close contact tend to vibrate, when it is open, little bit small changes will be vibrated. Suppose you can take the mobile. If you lock the mobile, screen lock, while opening some, if you want to give the select the vibration is allowed automatically to vibrate, that it indicates that device is open. Otherwise, that device is closed before the time, or it may be shut down the system in the final position. And the switching debounces also, always it will produce the noisy transitions, and also noise can interface with the proper operational logic circuits. How it is operation is performed? See here, this is a switch debouncing with SR flip flop. These two are S and R. Here these two are short circuited. You will get the output is Q bar. Q bar will not get, that will be short circuited. You can use to the switch bounds of this SR flip-flop. See here, when it is press the switches, it will be on, otherwise it will be off. When it is switch is open, automatically this is the vibrating operations. Here bounces, this is also bounces. When it is full down resistor is connected to contact A and B, assure that when all the switches in between A and B latches inputs also SR will always will be logically 0, then latch output will not be changes. That is the operation how it is performed to the switches T bounces. Here in the SR flip flop also you can take the S complementary as well as all R complementary. What is the output will get? Same thing, only it will perform to the S set and reset latches. Next we'll go for the gated gated latches. In the gated latches also you can use the help of SR flip flop only. You have to design gated latches. While designing the gated latches, no need to use for clock pulses instead of using to the SR flip flop. If you're designing SR and JK or D and T flip flop, will use to the, it will all the flip flops, it is depends upon the clock pulses, but gated latches it will not depend to the any clock pulses. Just it will replace to the SR and SR flip flop. You have to short circuited, you can assign the gated clock inputs. See here in the gated latches, have a additional input is called as gate or enable input. When the gate input is inactive, then the state of the latch cannot be changes. When the gate input is active, the latch is controlled by the other input, and also it will operates as a indicated in the proceeding section. That will see the gated latches. See here, when you are using to the gated latches, if you are selecting the data inputs, s is equal to 1, gate is also 1, r is also 1. What is will be the output will get? See here, first one you can see this. Uh, my input is 1, this is also 1, you can take 1, this also 1, 1, 1. What is the NAND gate of 1 1? We'll get the 0 0. Then you have to take act as the input is 0, this is also 0. Then what you have to do, what output will get? This act as a input of this. What output will get? Act as a input. Then you will get the q bar of this equation. See here, another reason for using to the disallowing the S is equal to R is equal to 1, the input combination is by considering a changes to the gated 1 to 0 when it is S and R is equal to 0. Suppose S and R is equal to 0 1 and 1 0, you can get it will be changes to the 0 to 1. That you have to keep it in your mind for external examination. When the gated it will be changes both input to the basic SR latches changes from 0 to 1. This cause both gates in the basic SR latch to attempt to change the from 1 to 0, 0 to 1 by using the race condition exist. And also you can use to the propagation delay of the gates, and also you have to determine whether the latch is stabilized or not by using to the output for the suppose q is equal to 0 or q is equal to 1, that you can whether it is stabilized or not. If it is a 1 1, it is stabilized. If it is a 0 0, also stabilized. When it will be changes to the 0 1 and 1 0, it is not stabilized for the q and q bar. That is for how it is performed to the gated latches. Suppose if you are using the q plus as a static one hazard for the input combination, you can take the gated is equal to 1, S is also 1, R is also 1, Q is also 1, and also you can take the another trial data inputs. Gated is equal to 0, S is equal to 1, R is equal to 1. We'll get the data is Q is equal to also 1. When the gated will be changes from 1 to 0 and 0 to 1, in between these two input combinations in the possible for the Q will be changes from 1 to 0 or 0 to 1. That because is the glitch is given to he simplify the by using the k map. This is for you can take the k map, how it is perform the k map. This is one quad. This also you can take the quad. This is also fair. You have to simplify with the gated latches. Final what gated latches it will be performed, you can see q and q bar. Then only you can find out the how much short time it will be time will get for the short time in the communicating any mobile devices. Suppose you can take the any one gated latches problem. Suppose if there is any restriction by using to the SR flip flop, it is not possible to use for the, or it is not possible to trace, or it is not possible to synthesize the data in gated latches. If you want to verify and synthesize in the gated latches, you have to use for the SR flip flop. Other flip flop it is not possible. When S and R inputs are must be changing or containing the glitches when it is gated is equal to 1. For example, you can assume q is equal to 0, gated will be changes to the 0 to 1, then it will be changes for the s is equal to 0, r is equal to 0, then it will be changes for the uh, q and q bar. Suppose if s and r is equal to 0 until gated returns to the 0, then q remains at will be 0. When it is s and r is equal to 0, when it will be until returns to the gated act as a 0, then remains q will be 0. Suppose if s contains a one glitch due to the static one hazard, then the q may be forced to 1 and will remain there, after G becomes 0. In the same thing, similar problem also can occur by using the SR flip-flop. Suppose S does not change from 1 to 0 until after G changes to the 1. This is also you can refer for the one bit of catching problem. So you can avoid S is equal to R is equal to 1 to the next of D latches. See here in the gated D latches, you can take the, it can be obtained from the gated SR latch by connecting S to D and R to D. See here, this is the D flip flop they are used. With the help of D flip flop, they are used for the SR flip flop. See here, data input, you can take only one inputs. What output will get in the perform? You can see the timing diagram as well as basic logic gate. This is a symbol of D flip flop. This is a truth table. How they simplify by using the Q plus, and also you can find out the Q also. That is the how it is perform the operation. Suppose any unreliable gated D latches, you can use the most digital system, use a clock signal to, and also you can synchronize the changes in the output of the system. Suppose if the flip flop and edge of the clock signal either positive or negative edge of the clock. Suppose if the flip flops where the clock signal is connected to the gate inputs of the latches. These are the gated latches. You can take the one more gated latches with the help of XOR gate. In this circuit zone, when the clock is equal to 1, so Q is equal to Q dash when the input X is equal to 1, and Q is equal to Q when X is equal to 0. When the clock is equal to 1 and X is equal to also 1, the D flip flop of T, and what is the output for the Q. When the Q will be changes, automatically clock will be remains 1. When the Q will not changes, clock will remains close to be 0, that it will maybe clocks remains to closed. The changes in the Q will feedback also you can use by using the Q changes. Also if it will be changes for the clock remains 1, when it is Q will be oscillate. Suppose in the circuit only in operated indented, if the clock remains is enable equal to 1, that will be short time. It has to 1 just long enough to allow Q to change, but short enough to prevent the change from the uh, feedback causing second changes. See here, when the within the single latch, it may be possible to control the clock and also high time so that latch is operate and intended, but in a system with several latches, the variation in the gate delay would make it impossible to provide the correct clock with all the latches. Then you have to avoid this timing problem more complicated. Suppose if you are avoiding the um, timing problem, just it will be more complicated for the flip flops, but you don't avoid the any timing problem in the flip flops, then only you will get the proper simulation. Also you can verify properly how it is performed the using the timing problem. That is indicate you have to use the clocks. When it is restrict the flip flop output to only change on an edge of the clock, and the output cannot be changed at other times even if the input is changes. When if even the input will be changes, the flip flop only need to stable. Okay. When the short period of time around the clock edges, you can refer to the flip flop, or you can use to the edge trigger. In the term of master and the slave, flip flop referred to as a particular implementation. Also you can use to the two gated latches. Also you have to use the flip flop output only change in the clock edge. Next, you can take the, this is one lab experiment. Design a gated D latch using only NAND gate, and you can use to the one more inverter. See here, this experiment I will show you in the lab experiment, and I will design, and I will synthesize, and how to select the data input, and how to verify the data output also I will show you in the lab also. Okay. Next you can see uh, edge trigger D flip flop. That is nothing but you can take the edge trigger D flip flop. Okay. Now you can see here, if the output of the, if the output of the flip flop can change the response to the 0 to 1, based on the clock inputs. Suppose flip-flop is trigger on the rising edge, that is indicate rising edge is nothing but either positive or negative of the rising edge. Okay. Suppose if the output can be changed the response to the 1 to 0, and the clock input you can say flip-flop is trigger on the falling edge, negative edge of the clock, falling edge will be trigger. In this term, active edge, you can take the refer to the clock edge, either it may be rising or falling the flip-flop, it will be changes. See here, this is the edge trigger D flip-flop. This is for the D flip-flop. This is also D flip-flop. How it is performed to the, this is rising edge, this is for the falling edge. Only small changes to the, while taking the selecting the data input for the rising edge and falling edge. Rising edge is nothing but you can consider as a ones, and falling edge you can consider as a zeros. Okay. Now, while using the D flip-flop rising edge trigger, you can see in the rising edge trigger, D flip-flop can constructed in the two gated latches as well as inverter. See here, these two are gated D flip-flop. You can construct it to the inverter with the help of clock. The D flip-flop rising edge inverter clock. This is the timing diagram. How it is performed to the rising edge. These two are rising edge. This is also rising edge. This is a line will be falling edge of the D flip-flop. How it is performed, you can see here. When clock is equal to 0, G1 is equal to 1, the first latch data input, because G2 is equal to 0, second latch will be hold the current value of Q. When the clock is equal to will be changes to the 0 to 1 or 1 to 0, current value of D is stored in the first latch, and also same time the value will be stored to the Q is equal to P values. Suppose when the clock changes back to the 0 in the second latch, it will be take the value of P, just it will hold it, and then first latches it will be start from the D input again. If the first latch it will be start to the D flip flop input before the second latch, it will takes the value of P, and flip flop will not be function properly. Okay. Now, if therefore if the circuit designer must pay to the careful attention to timing issues as well as designing edge trigger flip-flop. With the help of this circuit, you have to find out the what is the output status. Output state will be changes only following the rising edge of the clock. The value of D at the any time of rising edge of the clock, it determine the value Q, and extra changes to the D and occur between to the rising clock edges have, there is no affected in the Q. Here, because while using the any flip-flop, it will be changes state only on the active edge of the clock. The propagation delay of the flip-flop is in the time between to the edge of the clock and resulting changes in the output. There are also timing issues associated with the D flip-flop input. How it is function will be properly when the D input is edge trigger flip-flop must be held at constant value for the period of time before and after active edge of the clock. Suppose when the D flip-flop it will be changes in the same time, the active edge will be unpredictable. That it will be where is unpredictable. The amount of the time, and also with the help of D flip-flop, it can stable before active edge is called as setup time and hold time. The amount of time D must be hold the same value after the active edge is nothing but holding time, before active edge time is setup time. This is how to find out the setup and hold time for edge trigger flip flop. This is for the TP is for the setup time, hold time. You have to calculate the positive triggering and positive trigger of the edge trigger. In this time, when the D flip flop is allowed to changes during the clock cycle, the shaded timing to it be diagram. This is here shaded timing diagram, it will be changes. When the propagation delay clock changes until the output changes will be indicated. See here, this is for propagation delay. In the same thing, you can take the construction of the two gated latches, and using the two gated latches in the setup time allows to the change in the D as well as propagation through the first latch before the rising edge of the clock. The hold time is also required to D flip flop. The D flip flop it will gets and stored in the first latch before the D flip flop will be changes. In the same thing, you can take the determination of minimum clock period. How to take the minimum period clock period? With the help of D flip flop, you can use the feedback of NOT gates. While using this clock and Q divided by, we can flip flop delay will be 5 nanoseconds. That inverter also it will be delay 5 nanoseconds. This is the how it is performed to the edge trigger flip flop. Hello, hello,
Yeah, sure.
hello. Okay, this next class I will continue time off. And if you have any doubts, any problem, you can message me. Okay.
Okay,
Okay,
sir.
sure.
Okay. Thank you.
Thank you, sure.
Okay. Thank you.
Permutation is the arrangement of elements. Arrangement of elements. Suppose you have two letters A and D. In how many ways can you arrange this?
Sir, not audible properly, sir.
Is it? Wait. Am I audible now? Can you hear my voice? The students?
Yes, sir.
Yeah.
Not audible, sir.
No, no, it is your problem, man. I think it is not the problem from this side because the other students are hearing me. It may be your problem. Check your internet connectivity. Okay. See here we have two letters, two elements, two objects. My question is in how many ways? In how many ways we can make arrangement? In how many ways we can arrange this? Yes,
Two.
two ways. What are those?
First is how it is. Then second is change their positions, interchange, switch their positions.
Yeah. One is AD, one is A, then D. The other one is DA. So this is the arrangement of elements. This is one arrangement, this is another arrangement. Now let me give you some more letters. A, B, E. In how many ways we can arrange these three?
9 ways, sir.
9 ways. Check once again. Girls, no answers from your side. Yes, simple problem, simple problem. High school problem, you are taking so much of time. What is this? In how many ways we can arrange this?
6.
6 ways. 6 ways, right? Good. See, the answer is now I'll give one more. Along with this, let us take one more letter F. How many ways? All at once. In how many ways you can arrange?
24.
24. How you got the answer? 24.
Factorial, sir.
Factorial. Very good. The answer is on the board only. The answer is on the screen. See here. This P of, listen carefully. This P of n comma n. This P of n comma n means that arrangement of n elements, arrangement of n elements, taken all n elements, taken all n elements. How many elements we have? 4. And how many elements we are taking for arrangement? All 4. We are arranging all 4 elements. We have 4 elements only, and we are arranging all at once. So it is 4 comma 4, P of 4 comma 4, that is 4 factorial. 4 factorial. 4 factorial. So 4 factorial is 4 3 is 12. 12 to the 24. Now I will ask you, this is your set. This is your set. Now I ask you to take 3 elements. Take 3 elements from these 4 elements and arrange. I want you to arrange any 3 elements. How many such subsets, how many such arrangements you can make? You need to pick any 3 and arrange. You need to pick any 3 that is A, B, E, then you arrange. Arrange these 3 elements again. Then again go for the other 3 elements. Again you start arranging those. So how many such arrangements can you find? What I said, among these 4 elements, take 3 at a time and arrange. Then again take another 3 at a time, again arrange. Again 3, take the other 3, again arrange. So how many arrangements you can make? How many arrangements you can make? Can you give me the answer?
72, sir.
How you got 72?
So factorial of 3 is 24, sir. So 24 into 3, 72.
Okay, in the other way you have gone. The formula for that is this. You check in this formula. What is the answer? N is 4. N is 4. You are considering for your arrangement 3 elements. You are considering the 3 elements for your arrangement at a time. Your total number of elements N. Your arrangement is on 3 elements. Any 3 elements. Use this formula and find out the answer.
24.
How many?
24.
24 you got. It is 4 factorial. 4 minus 3 is 1. Yeah. What's that? 24. Yes, correct. So there are 24 such arrangements. See, if you have n number of elements, among that if you are taking r number of elements for arrangement, how many such arrangements you can make is this formula. This is the formula. Arrangement of r elements, okay, taken from n elements, taken from total n elements. Okay, let us move now. Generalization. Suppose it is required to find the number of permutations that can be formed from a collection of n objects. Okay, we have n objects. Suppose this is one object, this, and so on and so on. So many n number of objects we have. So these are n objects. These are n objects. Then what they say, of which n1 number of objects are of type 1. Suppose these objects are of same type. Suppose these objects are of same type. Let us take this as this is also E, this is also E, and this is also E. The letter E is repeated 3 times. So 3 objects are of same type. 3 objects are of same type. and another n2 number of objects are of second type. Say these three are only two. Suppose these two are of same type, say A. These two are of same type, A. And nk are of kth type in general. Say some other elements are of some other type, and there may be only one element of other type. There may be, say, F, and say all these are some say B. All these are of type B. So here, not all objects are distinct. What we observe, not all objects are distinct. Some objects are repeated. Some objects are repeated. In that case, see here, if you arrange these two, if you interchange these two, then also the arrangement looks like the same. If you interchange these two, then also the arrangement looks the same. Only this E comes there, that E comes there. There is no difference. So number of arrangements differs here. If all the elements are different, all the arrangements will be different. But in this case, where the elements are repeated, when you arrange these two places, E here and here, if you interchange, it looks same. So we require advanced formula. For this. How many permutations can we make if the elements are repeated? Some elements are repeated. Now let us see what is the formula. See, they are saying then the number of permutations of n objects taken, all of them at a time, taking all into consideration, how many arrangements we can do in this case when the elements are repeated. So this is the formula. What is the formula? N factorial divided by n1 factorial. That means n1 factorial means, suppose here 3 is repeated for 3 times. Sorry, E is repeated for 3 times. We can write divided by 3 factorial. Divided by 3 factorial, because this E is repeated for 3 times. That's what they are saying. See, n1 objects are of same type. So here 3 objects are of same type. So we divide by 3 factorial. Here 2 objects are of same type. So we divide by 2 factorial. Here only one object. So we can divide it by 1 factorial. We are just grouping. Suppose here 10 objects are of same type. We divide by 10 factorial. So what we do? The formula is n factorial divided by groups 2 factorial, 1 factorial, and so on. See, that is the formula we have here. You understood the concept? You understood the formula? Okay. Now based on this formula, let us take one important problem. The question is, how many arrangements are there for all letters in the word sociology? Can you apply this formula and tell me the answer? Apply this formula and tell me the answer. Group it. See here, O is repeated how many times? Can you count and tell? O is repeated for
3 times.
3 times. So we divide by 3 factorial there. And S is only one time. S is, it is repeated only one time. And C is repeated for
2 times.
2 times. So we divide by 2 factorial. So similarly, whatever is repeated, we divide by that. So how many letters are there in total? Can you tell me how many letters in total?
12.
So we do 12 factorial, 12 factorial divided by these things, 3 factorial into 1 factorial into 2 factorial and so on. We write in the denominator. Can you do and tell me the answer? You can do the factorials, factorial and all in your calculator. Check your calculators, scientific calculator. You can do these things directly in the calculator. First, you need to write the formula. Write the formula and substitute the things. Then you go for the calculator. Directly, don't jump to the calculator and give the direct answers. You have to write. Okay, tell me the answer.
Sir, 99,79,200, sir.
Oh, very good. Some answer you got. Let us check. What about the other answers? Other students, have you people got the same answer? What he is saying? Repeat your answer once again.
399,168,00.
99.
399,168,00.
You are the same student or the other student?
99,79,200 I got, sir.
Other answer. So then there is a confusion. Okay, let us go to the answer now. Yeah, the first student was correct. Check your answer, first student. Is this the answer you got?
Yes, sir.
See, use your calculators. How did you do the first student? How you did calculation?
Sir, applying the factorial, sir.
In the calculator only?
No, sir, manually.
Manually. So you expanded this 12
Yes, sir.
factorial
Yes, sir.
and you cancelled the terms.
Yeah, sir.
Huh?
Yes, sir.
Okay, after cancellation you went for calculator.
Yes, sir.
Okay. Okay, fine. See, this student got this answer. How many of you got, man? You girls? No sound. Sheetal. Sheetal. Sheetal, are you there? Unmute. Sheetal. No sound. What is this? Safina, Fatima.
Yes, sir.
Yeah, you are doing?
Yes, sir.
Okay. What answers you are getting?
Same thing, sir.
Okay, then why you people are not giving the answers? Okay, fine. Now let us go for the second one. First sub question is over. First sub question we did. Now, in how many of these arrangements, A and G are adjacent? See the question. So these are all the arrangements. So many, no, lakhs we have, 99 lakhs, and no, so much of money you got. Okay. Among these number of arrangements, you need to find out the arrangements, in which A and G are adjacent. How will you do this? Any idea? Any idea you got? We need to find among these arrangements, you can have some arrangements. Where A and G are adjacent. A and G are adjacent. Friends, ಒಂದೇ ಬೆಂಚಲ್ಲಿ ಕೂತ್ಕೋತಾರೆ ಅಕ್ಕಪಕ್ಕದಲ್ಲಿ. ಎ ಜಿ ಹೆಂಗಿರ್ಬೋದು ಅಥವಾ ಜಿ ಎ ಹೆಂಗಿರ್ಬೋದು, ಬಟ್ adjacent. In how many such arrangements A and G are adjacent? AG or GA, both are okay. Okay, time is getting over. Let me explain. Listen very carefully. Let me draw one arrangement here. Suppose this is one arrangement of what? Sociological. Suppose this is one arrangement of sociological. Some arrangement we have. I want A and G to be adjacent. I want A and G to be adjacent. Always these two should be adjacent. So why not I make this as a single letter? Let us make this as a single letter, because always they are sitting together. Let us make this as a single letter, A and G, single letter. Then how many letters are remaining? If you make A and G as a single letters, how many letters are remaining? Can you
11.
count?
11.
Total 11, right? Yes, correct. Because when you make A and G as a single letter in this word, so total number of letters will be 11 then. 11. So among these 11, what we do is we apply the formula factorial divided by, again we start counting. S is repeated for how many times? One time. S is repeated for one time. Now O is repeated for 3 times. And then C is repeated for 2 times. Then I is repeated for 2 times. Okay, I is repeated for 2 times. Then what? I over I, O over L. L is repeated for 2 times. Okay, then O over G is here. We can't count G, A and G. A and G is repeated. That is A and G. Along with that, A and G we have taken X. X is repeated for one time. AG, that is X, is repeated for one time. Yeah, apply this formula and check your answer. Fast.
1108800.
Very good. Some answer you got. Suppose you got some answer. Double one. What? Can you tell me again? Double one.
110
Double 10.
88
Double 8.
00.
So this student has got this answer for this. Now listen very carefully. Now here is a small improvement in the answer. Small improvement. Nothing. Here we had considered A first, G next. For A first, G next, these many permutations. When you go for G first, A next, again you will get same number of permutations for that also, because we are considering as a single letter. But arrangement changes. See here, arrangement changes. AG is different from GA. For AG, so many permutations. Again, when you make it GA, all these permutations get changed. When you make it GA, again new permutations you are going to get GA with GA. Again the same number repeats. So what I do to this answer, I multiply by 2, because 2 times. Because inside this AG I have 2 permutations. Inside this AG I have 2 more permutations. So whatever answer I get, I multiply it by 2. Let us see the answer for this one now. Let us see what is the answer now. This student said this answer. Let us check whether it is correct or not. Into 2 you do. The student, you gave the answer. You do into 2 and
Yeah, sir. Same answer.
same answer you are getting after into 2. This answer. Are you getting this answer?
Yeah, sir. 60 lakh thousand, 60
Good.
lakh 63,200.
Okay, good. See here we did that by taking AG these many permutations. When you go for GA, again same number of permutations. That's why we are multiplying by 2. So this we did. We did this.
Sir,
Yes.
through calculator, how we can do it, sir?
To calculate in calculator.
Yeah.
In calculator, there is some option for n factorial in calculator.
Sir,
You
it
see,
will
n
be
factorial is
shift
there.
plus logic, sir.
Huh?
It will be shift plus logic in FX991 MS, sir.
Come again, slowly you tell, man. Slowly you tell how to do.
Sir, in calculator, shift
Okay.
plus X bar minus 1 button is there, sir.
Shift
In right,
plus
X bar minus 1.
x to the power minus 1. That is n factorial, no?
Yes, sir.
Yeah. See what he is telling. Okay, we need to press that, no? For this shift plus n factorial. Then you have to go for divided by option, right? You have to go for divided by option, and then you have to open the brackets. Again shift plus n factorial and all you can do. Again open the bracket and all. Check this in your free time. Learn how to calculate.
Sir, after that 3 factorial plus we need to add, sir. Plus
No,
2
Into.
factorial.
Into
Okay.
and you have to be very careful with the brackets. Be very careful with the brackets. It depends on what type of calculator you are using. If it is well advanced, if you miss few brackets, then also it will consider. But in old versions, you have to be very careful in brackets. Okay, now think of the third one. All the vowels, are adjacent. Oh, all the vowels are adjacent. How many? What are all vowels we have here? Can you identify?
A, I, O.
Very good. A, I, O are adjacent. Now let us. How many? Let us first draw this. A. How many A's are there? Only one A. Fine, good. Only one A. How many O's are there? A, I, no, I. Okay, I will go for I. Two I's. I, I. How many O's are there? 1, 2, 3. 1, 2, 3. So what we do first? First we will make this as one letter. First we will make this as one letter. So how many letters will be there in total then? If we make this as single letter, 1, 2, 3, 4, 5, 6. Yes, how many letters will be there?
Six.
6 plus 1, 7, because this is one letter, because all vowels all together is one letter. Apart from this, 1, 2, 3, 4, 5, 6, 7. 7 letters are there, because this also has to be considered. 7 letters. Okay, we have less than 1 minute. We will continue in the next class. Okay, bye. Try to do this problem.
बाय बच्चे
Bye, bye, students. Bye. We are.
Good afternoon, students.
Good afternoon, ma'am.
Am I audible clearly?
Yes, ma'am.
Yes.
Okay, fine. Let's continue. Laplace transforms of split functions. We did in the morning two with a function with two splits. Let us solve another problem where you have three splits. Okay. So in the same vein, the problem is evaluate the Laplace transforms of the following functions. Okay. Heavy side of the following heavy side functions. Question is like this: f of t is equals to, it has three splits here, 1 t and t square. So let's see, 1 t and t square. All right, as it has three splits, we have three different intervals. What are they? It's 1 in the interval 0 to 1. Again, in the interval 1 to 2, the value of the function is 2. Again, when t is greater than 2, you have the third part. Right? Now, let's see, how do we write? I gave you the property already in the morning. We have the last property here. What does it say? F of t equal to f1 of t plus f2 minus f1 of t into u of t minus a plus f3 minus f2 of t into u of t minus b. And here a is 1 and b is 2. Okay, so let's apply the formula. So this fourth property what we discussed in the morning. So we get this function f of t therefore is equal to f1 of t is 1 plus t minus 1 into u of t minus a here is 1 plus f3 minus f2, which is going to be t square minus t into u of t minus 2, the upper interval here. Understood? Applying Laplace for every term, we get L of f of t therefore is equal to, what is L of f of t? L of 1 plus L of t minus 1 into u of t minus 1 plus L of t square minus t into u of t minus 2. Okay. All right. So applying the Laplace transforms here, we get, as I told you, let us assume A, B, and C as three parts here. There are three different Laplace functions to be found. Okay. What does A state here? L of 1, which is equals to 1 by S. Second part is B, that is L of t minus 1 into u of t minus 1. How does it look like? This is similar to L of f of t minus a into u of t minus a. Where what is a in this case? This implies a equal to 1. Understood? So what is f of t minus a, by the way? f of t minus a, when you compare with this is equals to t minus 1. This implies what is f of t? You have to write for this function, t has to be replaced by t plus 1. T plus a you should take, I told you. So when you put t is t plus a, you'll get t plus 1, t minus 1, which is going to be just t. This implies L of f of t will be equal to L of t, that is equal to 1 by s square. So this is our f bar of s. This implies L of t minus 1 into u of t minus 1 is equals to e power minus as. As is 1s into f bar of s. That is e power minus s into 1 by s square. Now coming to the last part. Okay. So when you compare this with the standard one, we get a is 2. This implies f of t minus a in this case is equal to t square minus t. So what will be f of t? That will be t square minus t. Here t is replaced by t plus 2. So replace it. We get t plus 2 the whole square minus t plus 2. So simplify that, expand the whole square and simplify that. Otherwise, you can simplify as it is. You'll get a product, right? So why to risk? Okay. So this implies f of t will be equal to t square plus 4t plus 2 minus t minus 2. Okay. Again, simplify ahead. You'll get t square minus 3t. That's it. Plus 2 minus. Okay. Sorry. This is 4 dear. So it will be plus 2. Okay. So that's what is left off. So L of f of t hence will be equal to L of t square minus 3 L of t plus L of 2, which is equals to t square will become 2. The factorial is 2 divided by s power 2 plus 1. Again 3 by s to the power 1 plus 1 plus a by s. This will be our f bar of s for this case. So L of t square minus t into u of t minus 2 is equal to e power minus as. In this case, a is 2. So e power minus 2s into f bar of s, which is equals to e power minus 2s 2 by s cube minus 3 by s square plus 2 by s. So this is the third part. Just write one first part plus second part plus third part, you'll get your answer. So what will be therefore L of f of t will be equal to, what is the first part of answer? 1 by s plus answer in the second part e power minus s1 into 1 by s square. Last part e power minus 2s into 2 by s cube minus 3 by s square plus 2 by s. Okay. Understood, everybody?
Plus 3 by s square, no, ma'am.
Tell me, dear.
Last third line, ma'am. It should be plus 3, ma'am.
Why? Oh, yeah.
You have written.
Yes, you're correct, dear. Sorry. All right. Is it clear enough? Others? See, this type of problems, that is problems based on periodic function and problems based on unit step function, most of the time will come one question each from both of them. Possibility is there. Understood, guys? So you have to concentrate, and there are so many miscellaneous problems here. You guys can solve under this. Additional problems are there for unit step function. You try solving those as a practice for yourselves. Okay? All right. Any doubts?
Oh,
Others? Okay, then this ends up our first part of the module, that is Laplace transforms. Now let us start up with inverse Laplace transforms. Shall I rub the board? Shall I rub the board, man?
1 minute, ma'am.
Okay.
Yeah, ma'am.
Others? What, yeah? The strength is very, very less. Hmm? Okay, guys. So let's proceed with the next part. And one more thing, there will be an hour class on Monday, guys. Monday, basically it's a holiday, so you don't have the regular online classes, but I will be taking 1 hour class on Monday. Okay, that means 2 sessions it will be there. Everyone
Tomorrow,
has
ma'am.
to join. Monday. Tomorrow day
Ma'am,
after
tomorrow
tomorrow,
classes are
I don't
there,
think
ma'am,
the festival
tomorrow.
also will be there. Because of festival, I don't think there is the classes will be there. Okay, but whatever it is, Monday there will be an extra class for math. I will send you the link. All of you have to join. In the afternoon, I'll take around this time only, 3 o'clock. Okay.
Okay, ma'am.
Everyone, please inform in other groups as well. Today's strength is very less. Anyways, let us continue with the next part of it. Now we are going to discuss the second part of the Laplace transforms. We just till now did the Laplace transforms, right? Now we will see what are inverse Laplace transforms. Inverse Laplace transforms. Okay. So what are inverse Laplace transforms, dear? I have given you the definition in the beginning. Just one line only I told, I remember. We know that L of a function f of t is equal to f bar of s. So introducing L inverse on both sides. So we get L inverse into L of f of t will be equal to L inverse of f bar of s. So if you rearrange it, this L inverse and L gets nullified. Now we can write L inverse of inverse Laplace transform of f bar of s, therefore is equal to f of t. This is the basic definition. Understood, everybody? So how do we imply this? See, we know that Laplace transform of a constant a is a by s. So this implies the inverse Laplace transform of the answer part, that is a by s, should be equal to a. That's how it is. Understood? So based on this, let us make the table for the inverse Laplace transforms of the elementary functions. So all of you make this table. Inverse Laplace transforms of elementary functions. Okay. So what is that? Let us see. First, we know that first one, we know that L of I will start with this. L of A is equal to A by S implies L inverse of A by S will be equal to A. Okay. So particular case, what will be the particular case? L of 1 is equal to 1 by S implies L inverse of 1 by S will be equal to 1. In general, if you take out the constant, it will just become 1. Okay. Similarly, we know that L of e power at is equal to 1 by s minus a. This implies L inverse of 1 by s minus a will be equal to e power at. Again, one more case. We already did this. E power minus at will be equal to 1 by s plus a. So L inverse of 1 by s plus a will be equal to e power minus at. Okay. Next, third one, Laplace of cos at is equal to s divided by s square plus a square. Therefore, L inverse of S by S square plus A square is equals to cos AT. Like that, you have to invert it and then remember. Again, we have a similar thing, L of sin AT. A by S square plus A square. So L inverse of A by S square plus A square is equals to sin AT. Okay, if I have to take the particular case here, because every time we don't have the constant. So what we'll do, we'll take the A down. So you can remember here, therefore L of sin t is equal to 1 by S square plus 1. That implies L inverse of 1 by S square plus 1 is equals to sin AT. Okay, so L inverse of 1 by S square plus 1 is equals to sin t. Sorry for that, guys. So first you should certainly have a yes in the numerator. But for sin, if you just have 1 also, that's sufficient. This can also be written as L inverse of 1 by S square plus A square is equals to sin AT divided by A. Like that, you can remember that. Understood? Similarly, let us talk about the hyperbolic functions. We know that Laplace transforms of the cos hyperbolic will be equal to cos S by S square minus A square. This implies L inverse of S divided by S square minus A square is equals to cos hyperbolic AT. Okay. Again, sin hyperbolic, Laplace of sin hyperbolic is equals to A divided by S square minus A square. So this one, here also you can take out A. If you keep A, you can let it be. If you don't have A also, we can write this just like sin. Just like sin, even if you don't have A goes down, this becomes 1 by A here. Here also A can be taken down, it becomes 1 in the numerator. Okay. So you can use it in both ways. Okay. People are still joining. See. Okay, so this is for sin hyperbolic and cos hyperbolic. Also, we have those functions, if you remember. What are those? Laplace of, what is that? T power n. When n is a natural number, 1, 2, 3, and so on. What is it equals to? N the factorial divided by S power n plus 1. So, n will be a constant, right? You can bring it down. Therefore, L inverse of 1 by S power n plus 1, when n is a natural number 1, 2, 3, and so on, we can write it as T power n divided by n the factorial. Understood? Because n is a constant, it goes to the denominator like this. That's how you can write. So, what is the inverse Laplace transform of 1 by S square? 1 by S square means you should write it as 1 plus 1. You identify always n is 1 less than that, right? So if this is n plus 1, 1 less than that will be n. So you will get 1 by S square. The inverse Laplace transform will be t by 1 the factorial, which is going to be just t. Like that. That's a simple case. And of course, you have the gamma functions also in the same way. Laplace of t raised to n in general. We know that this is equals to gamma of n plus 1 divided by S power n plus 1. Here also we do the same thing, L inverse of 1 by S power n plus 1. Because gamma function values are always a constant value, so it's going to be t power n divided by gamma of n plus 1. So these are the elementary formulae where I have given for you both Laplace and inverse Laplace so that it is easy for you to compare. Got it, guys? You should learn these in the same format and I will show you how to solve them. How to apply them for simple problems first, and later we'll see different situations. Understood? Everybody? Quickly write this. I will rub the board. In the textbook, the list is there, but only it is for the inverse Laplace. Got it? All of you?
Yeah.
Shall I rub the board, guys?
Yes, ma'am.
Okay. Now remember the list what I have given you. From that, you should keep answering me. We will start solving some simple problems using this, whatever the list I gave you. Okay. Let's see a question to find the inverse Laplace transform of s plus 2 divided by s square plus 36. Next, plus 4s minus 1 divided by s square plus 25. Okay, so we have to split it now. Split everything. There are two terms. Even though two fractions, we can split it like this. L inverse of, we'll separate them because we don't have inverse Laplace for single term, merged term. So you have to get separate terms, just like integration. How you can't do it directly. But once you get the hang of this is very easy, dear. I'll tell you again and again. See, inverse Laplace and Laplace both are easy. Only you have to understand what it is clearly. And remember the basic formula. Minus 1 by s square plus 25. I'm splitting it. I'm not doing anything. Whatever they have put it in the form of LCM, merged terms, I've separated the fractions. Now applying inverse Laplace for every single term, we get s by s square plus 6 square, right? 36 is 6 square plus 2 is a constant. L inverse of 1 by s square plus 6 square. 4 into L inverse of s divided by s square plus 5 square minus L inverse of 1 by s square plus 5 square. That's how you should do it. See, single terms, everything. Now, what is Laplace L inverse of? Look at the list of the formulae what I gave you. L inverse of s by s square plus a square. What is this equal to, guys? Tell me, quick.
Cos 80.
Yes, that will be equal to cos 80. And what about this one? If I don't have an s, if I have 1, what will I get?
Sin 80.
Yes, is sin 80 by a. Whenever it is sin, you remember always a comes to the denominator. But for cos, it won't come. If you forget this, you will get wrong answer. Be very careful here. Is it clear? So, what we will get here now, this one will be cos 80, or a here is 60 plus 2 as it is into, the second one is 1. Therefore, sin 80, that is sin 60 divided by a, that is 6. Okay. Similarly, plus 4 as it is, this is again cos 80, a is 5, minus sin 80, a is 5 divided by a, that is 5. So, what is the final answer? Simplify only this gets simplified. I think everything else is same. No difference. Cos 60 plus 1 by 3 sin 60 plus 4 times cos 5t minus 1 by 5 sin 5t. That's it. You know the formula, you can do it easily. Understood? Who is that? Please mute yourselves. If you have something to tell, then unmute yourselves. Okay? Am I clear?
Yes,
Understood, everyone? Everyone understood this?
Yes,
Yes,
ma'am.
ma'am.
Yeah, we'll quickly do one more. All right, where we can see how we can do the little changes if they are. How can we do? Like the coefficient of s is not 1. In all the formulae, s square coefficient is 1. Otherwise, s coefficient is 1. If it is not 1, how can we solve? Let us see that. I'm picking randomly a few and I'm not solving everything because all these are simple only. Okay, so let's do one more where we can split it. Okay, again splitting only I will show you, but coefficients are not the same. That is L inverse of 2s, okay, 2s minus 5 divided by, no, other one is there which looks to be lengthy. Let us go with that. Yeah, 2s minus 5 divided by 4s square plus 25 plus 8 minus 6x divided square plus 9. Okay, so as I told you, 2s divided by 4, I will take out common s square plus 25 by 4 minus 5 divided by, again I'm taking out common s square plus 25 by 4. You cannot do it directly. S square coefficient should be always 1. If anything is there, drag it outside. Same here, the second term is also split into two parts. 8 divided by 16 is taken out, s square plus 9 by 16 minus 6s divided by 16 into s square plus 9 by 16. Now 2 and 4 gets cut, so you'll get 1 by 2 L inverse 1 by s square plus this can be written as 5 by 2 the whole square minus 5 by 4 as it is outside L inverse of 1 by s square plus 5 by 2 the whole square. Again, this will be 1 by 2, 1 by 2 L inverse of 1 by s square plus 3 by 4 the whole square. Again here, okay, minus 2 by, sorry, 3 2s, no, this is 3. So minus 3 by 8 L inverse of s divided by s square plus 3 by 4 ka whole square. Okay, so this is the condition. I hope you everybody understood similar to this, but only thing is like coefficients of fractions. So this is again L inverse of 1 by s square plus a square. Whenever you get s square plus a square, it's 1 by a. Otherwise, I will write sin at. A here is 5 by 2. So sin 5t by 2 divided by 5 by 2. Again, minus 5 by 4 as it is. This is again, sorry, this is s is there. I didn't see. So it's going to become cos. Sorry. So this will be cos. Cos at here, a is 5 by 2. So 5t by 2 minus 5 by 4 into, again, this is going to be sin at. So sin of 5t by 2 in divided by 5 by 2 plus 1 by 2 is as it is. Again, this is going to be sin at 3t by 4 divided by 3 by 4. Again, coming to this minus 3 by 8 into cos at cos 3t by 4. Okay, so you can simplify this. This is 2. So it's going to be go up 1 by 2 cos 5t by 2. Again here 5 gets cut, 2 and 2, so it's again 1 by 2 sine 5t by 2. Here it will be plus 2 by 3 sine 3t by 4 minus 3 by 8 cos 3t by 4. This is the answer. Understood, everybody? Any doubt?
No, ma'am.
Guys, don't open your mouth and ask me your doubts. How will I get to know? Tell me quickly. Huh? If you don't tell me that this is your doubt and that is your doubt, how will I get to know, guys? Anyways, this is only sin 80 cos 80 formula what we have used. Let's see what will be the other one. So one more question I will solve here. We have to find the Laplace inverse of 3s plus 5 root 2. 5 root 2 the whole divided by s square plus 8. Okay. S square plus 8. Okay. It's pretty direct. But anyways, you have to simplify again. We will use the same formula. Hope you guys can solve it. I didn't see yes there. We'll do the other one where you have all the fractional powers. That is 1 by s root s plus 3 by s square root s. Okay, minus 8 by root s. All these are having fractional powers for the s. So we'll use the gamma function thingy here. Understood? So whatever the gamma function thing what we have used there in the previous Laplace, we are going to use the same way here. All right. So how do we do that? First, let us write each and every individual term with its proper power. Okay. So how do we write with its proper power? Yes and root s. How much will be s and root s? S power 1 root s is 1 by 2. S into root s will become 1 by s power 3 by 2. Accepted? Same like this here. 2 plus 1 by 2. So 3 divided by s power. How much is 2 plus 1 by 2? 5 by 2 minus. Okay, 8 by s power 1 by 2. And we can take these up. It will become. Okay, let it be as it is
Minus.
only. Yeah, we have a formula here. What does the formula say? In the last formula where I gave you the gamma function, you can see 1 by s power n plus 1, right? So we can write 1 by, shall I rub this one? Is anybody writing this one? So that I'll get some space to write the formula. Shall I rub this problem?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So we have a formula L inverse of 1 by s power n plus 1 is equals to, where n is not a natural number, we have t power n divided by gamma of n plus 1. That is what we get. Okay. So how do we write this? Therefore, L inverse of the first term, but we write it like this only. How do we write it? S to the power 1 by 2 plus 1 plus 3 times L inverse of 1 by s power. How much is it? 5 by 2. If you split it, what plus 1 it will become? 3 by 2 plus 1 will be 5 by 2. So therefore it will become 3 by 2 plus 1. Again minus 8 times L inverse of 1 by s to the power half. What plus 1 is half? How do we write half as what plus 1? Minus half plus 1, right? We should always try to mention it as minus n plus 1 format only. Then only you can apply this formula. So applying this formula in all the cases, we get t raised to n. N is first case 1 by 2 divided by gamma of 1 by 2 plus 1 plus 3 times. Again here t to the power n is 3 by 2 divided by gamma of 3 by 2 plus 1 minus 8 times. T to the power n is t power minus 1 by 2 into gamma of minus 1 by 2 plus 1. This will become t power 1 by 2 divided by gamma of 3 by 2 plus 3 t to the power 3 by 2 divided by gamma of 5 by 2 minus 8 t power minus 1 by 2 divided by gamma of 1 by 2. And I have already given you the standard gamma values. So substituting the standard gamma values, what do we get? What is gamma of 3 by 2? Gamma of 3 by 2 is equals to 1 by 2 into root pi. T to the power 1 by 2 divided by 1 by 2 into root pi plus 3t to the power 3 by 2 divided by, and how much is gamma of 5 by 2? We have 3 by 4 into root pi, isn't that? Check it out. I have given you already the values. From that list only I am writing. Okay. 8t power minus 1 by 2 divided by gamma of half. Gamma of half is root pi. Okay. So now simplify again. You have denominators. In the denominators taking up, you get 2 root t divided by root pi. Actually, you have a 1 by root pi common from every term. Maybe you can take out here only. So taking that out, 1 by root pi is taken out. We will have 2 root t. 3 gets cut, 4 goes up. So plus 4 t power 3 by 2 means t root t you can write if you want. Otherwise, if you leave it like that also, it's not a problem. Anyways, so here 1 by root pi is gone out. So we have 8 by root t. 8 by root t. Maybe you can take out a 2 also common because 2, 4, 8, right? So if you take out 2 directly, we can write like this. This will be just 4. Leave it like this. That's it. This is inverse Laplace using gamma functions. Understood, guys? All of you? So tomorrow we will do particular type of problems to find the inverse Laplace transforms. We have completing squares and to find inverse Laplace using partial fractions. Those two are important, so we'll do those two. And then convolution theorem and applications of Laplace functions. Oh, I don't know. I want to complete the chapter by Wednesday. That's why there will be an additional class on Monday. Guys, please study all the formulae and take the class. Around 3 o'clock on Monday, I will take the class for 1 hour. 2 sessions. Understood, everybody?